Hey everybody. In class today we worked on a problem that taught us how to find a missing value by working backwards through the problem using inverse operations. That process, working backwards, is a great way to solve more complicated types of equations than we're used to seeing. In this case, we have an equation that says 2x plus 7 equals negative 5. Remember, if we have the order of operations, parentheses exponents, multiplication and division, addition and subtraction, normally we would follow the order of operations from top to bottom. Do them in order. PEMDAS, or please excuse my dear Aunt Sally. When we're solving equations and we're trying to find a missing value, we actually work backwards through the order of operations using inverse operations. This is when we are solving an equation. So in this example here, 2x plus 7 equals 5, we're going to do the same thing we did for one-step equations where we draw a line through the equal sign. Now this says 2x plus 7, so there's two operations here. There's multiplication and there's division. Now since I'm trying to solve this problem and we're going backwards, we are actually going to undo the addition first because that's closer to the bottom in the order of operations. To undo addition, we use subtraction, the same thing where we are using inverse operations. So, to solve here, instead of plus 7, we're going to subtract 7 from both sides. 7 minus 7 is 0. That cancels out. We're left with 2x equals, and negative 5 minus 7 gives us negative 12. Now we only have one operation left, and that's multiplication. So that's the second operation we're going to take care of after addition. So now to take care of the multiplication, to undo multiplication, the inverse operation is division. We divide by 2, and we divide by 2. 2 divided by 2 is 1. Left with x equals negative 6. Another thing we saw in class today was the importance of taking the answer you wind up with and putting it back into the problem at the beginning to see if it actually works. So here we have x equals negative 6. We're going to put it back into our equation here and see if this actually makes the equation true. So we have 2 times negative 6 plus 7 equals negative 5. Now we're going to evaluate the left side here to see if this side actually does equal negative 5. So 2 times negative 6, here because we are evaluating, we're going through the order of operations in the normal way. Please excuse my dear Aunt Sally. So 2 times negative 6 is negative 12, plus 7 equals negative 5, and negative 12 plus 7 does equal negative 5. So since this is true, we know that this is our solution. We can use this method, working backwards through the order of operations, to solve any two-step equation. In this case, negative 5 plus c divided by 4 equals 2. Once again, we have two operations. We have addition and division. So once again, we're going to want to undo the addition first. Now in this case, the addition is of a negative number. Plus negative 5. We have negative 5 plus c divided by 4. So we've got to think, how am I going to cancel that negative 5? I'm going to have to add 5 to both sides. Negative 5 plus 5 is 0. So that cancels out. We're left with c divided by 4 equals 7. c divided by 4 equals 7. So now I have to think, what's my inverse operation of division? It's multiplication. So I'm going to multiply by 4 times 4. Multiplication and division of 4 cancel out. We're left with c equals 7 times 4 is 28. Now, to make sure, just like we saw in the problem today, we're going to put that back into the beginning of the equation. Negative 5 plus 28 divided by 4 equals 2. Now, the order of operations tells us, now that we're evaluating, tells us to do the division before we do the addition. 28 divided by 4 is 7. So I have negative 5 plus 7 equals 2. Negative 5 plus 7 is 2. So this is a true statement. C equals 28 makes the equation true, so that's how we know that this is the solution to the equation. As you saw in the last two examples, to solve these equations there's always two steps. The first step is we always undo the addition and subtraction first. Always undo the addition or subtraction first, and then we undo the multiplication or the division. So we're going to go over two more examples here before we're done. In our first example, 7 minus 2x equals 10. We can start by drawing our line through the equal sign. Now we have to undo our addition or subtraction first. Now in this case we have 7 minus 2x. I want to leave my 2x alone, and I want to get rid of the 7 that we're subtracting 2x from. Now this is a positive 7. If I want to get rid of this positive 7, I can subtract 7 from both sides. 7 minus 7 is 0. Now we have to be very careful in this problem. Here it says minus 2x, right? We could think of this as plus negative 2x. So this 2x term is actually negative. We're going to write negative 2x equals 3. Negative 2x equals 3. Now this means negative 2 times x, that's multiplication. So we're going to divide by negative 2. Negative 2 divided by negative 2 is 1. We're left with x equals negative 1.5. So that's our solution. If we want to double check very quickly, we can do 7 minus 2 times negative 1.5 equals 10. Now 2 times negative 1.5 is negative 3, so this becomes 7 minus negative 3 equals 10. And we know that 7 minus negative 3 is the same as 7 plus 3. And 7 plus 3 does equal 10, so this is true. Here is our solution. In our second example, we have negative 2 equals 2/7 times x minus 4. We'll draw our line. Now in this case the x is on the right side, but we're not going to let that fool us. I'm still looking over here at the x. This is what I want. I want to isolate the x, so I have to undo multiplication and subtraction, but I always undo the subtraction before the multiplication. So I'm going to add 4. This gives me 0 over here, negative 4 plus 4. Negative 2 plus 4 is 2. We have 2/7 x over here on the right. Now this is 2/7 times x. Instead of dividing by 2/7, I'm going to multiply by the reciprocal. 7 over 2 times 7 over 2. Now on the right side, 2/7 times 7/2 equals 1. Those cancel out. We're left with 1x equals, now here we'll make that 2 over 1. 7 times 2 is 14. 2 times 1 is 2. So you got 14 over 2 equals x. But we know that 14 over 2 means 14 divided by 2. That means that equals 7. X equals 7. Now we can check this very quickly. Negative 2 equals 2/7 times 7 minus 4. I can make this 7 over 1 here to make it easier to multiply. 2 times 7 is 14. 7 times 1 is 7. 14 divided by 7 is 2. Negative 2 equals 2 minus 4. And 2 minus 4 is negative 2. So we get a true equation here when x equals 7.